I insert 50, no problem, I'm in balance. I insert 5. Remember, the front part of insert in an AVL tree is exactly the same as binary search tree. I follow the search path, walk off the search path, that's where I add the node. What's different is when I work myself back the path, which in your code is really returning from your recursion, then I have to check balance. So 5's less than 100, less than 50, I put 5 to the left of 50. Now I work my way back. Well, 50 is a node that's still in balance from the AVL rule. Its left side is 1 taller than its right, but that's okay. Work myself back. 100 is out of balance. Right? I have a left child that's 2 taller than the right. And this was one of the cases we've seen. This is a single rotation on the left. Right? How do you know that? You look at the taller side, in this case the left side, and see it's taller on its left side. So we're going to rotate this so that we end up with 50, 100, 5. In the pattern we had before, where we had S, X, A, B, C, it just so happens that B and C are empty in this case. Then we go ahead and insert 75. 75 is greater than 50, less than 100. So I put it to the left of 100. The new node you put in is always balanced, right? Because you're always putting something in a leaf. I go back to the 100, it's okay, its left is 1 taller than its right. I go back to 50, it's okay, its left is 1 shorter than the right. Right? Notice, as you look at nodes to determine the balance, you don't have to look everywhere in the tree. You're just reversing your path that you followed as you did the insert. Then I insert 2. Right? So 2 is less than 50, less than 5. 2 goes here. Everybody's still in balance. I insert the 80. Right? 80 is greater than 50, less than 100, greater than 75. I'm okay for balance here. I'm okay for balance here. I'm not okay for balance there. Remember, this was the smallest pattern for what we called the double rotation. Right? Remember, we had our S, our X, and our Y, and we had A, B, C, D. And the way you're going to restructure this part of the tree is Y becomes the root of that part of the tree. X is now its left child. Its right child is S. X's, in this case 75, left child, 7, would still be A. Its right child would be whatever was in B. For S, the 100 in this case, its left child would be whatever was in C, and its right child would remain D. But of course, they're all empty at this point. And then we have the 50, 5, and 2. And as I pointed out before, the height of this whole tree, or let's say the height of this tree that I did the rotation on, is the same as its height was before we did the insert. And that's why in insert, once you do a rotation, you'll never have any other balance problems. Okay? So that's the tree we have now. Then I go ahead and insert 12. 12. Less than 50, greater than 5. It can just go there. And we're okay as far as balance goes. Then I'm going to remove 50. Well, I have to find a replacement value. I'm again going to go get the largest value on the left. All right, that's the 12. I can remove that. Now notice, at the point you do the remove, you have to check about balance. So I go back up to the 5, but that's okay, its left side is 1 taller than the right. I go back up here, replace the 50 with the 12, and I am still in balance, because in fact the left and right children of 12 are the same height. Okay? Then I remove the 5. Again, that's the one-child case. I'll just go with 3 here. I'll get a 2 here. It's true I go back up to the 12, but I'm still in balance because the right side is just 1 taller than the left. Okay? And then I insert 90. So greater than 12, greater than 80, less than 100. Now what do we get here? We're balanced here. We're balanced here. We're balanced here. But we're not balanced here. The right side is 2 taller than the left. Now, what case is this? This is actually the mirror image of the single rotation on the left. This is the single rotation on the right case. Because here's my S. It's the node that's out of balance. It's taller on the right side. And if I look at the right subtree, it's taller on its right side. So sometimes this is referred to as the right case. Just like the single rotation case on the left was the left case. I was tall on the left and the left side was taller on its left. So the pattern I'm going to get here is I'm going to end up, this is my S, this is my X. All right? You can think of this as A, this as B, this as C. So I'm going to get X is the new root, S will be its left child, S's left child doesn't change, but its right child becomes this node I referred to here as B, and X's right child doesn't change. So remember, I had in the patterns I showed you this pattern. You have, say, the root of your tree, some path down to this parent. The parent has a child called S that was out of balance. Right? Could be the left or right child of the parent. Right? Then we have this X, A, B, C. And the situation here is S is out of balance because its left side is 2 taller than the right. And if we look at X, its left side is taller. And so we transformed that into this. That was our single rotation on the left, or the left-left case. What we really have here that we produced is we have this pattern. Our root, some path to P. P had a child S, X, A, B, C. And the situation is S is too tall on the right. If we look at the right side, it's taller on its right side. That is, X is taller on its right. And so we transform that into this. Right, obviously not going to look more distracted. Okay? Remember what I said here. S's right side's too taller than its left. We look at X, it's taller on the right side. So that's the right case for the single rotation on the right, and we transform it into that. So really, this and this are just mirror images. One on the left side, one on the right side. And that's what we did when we went from this tree to this tree. Okay? Now you're going to want to eventually know these patterns, right? So you can see them and know how to do the rotations. But after you do it a few times, you will just remember it, right? But it's worthwhile writing them down, looking at them, trying to understand what the situation is. Okay? All right, so here's where we are now. And I just inserted 90. I'll insert 200. Greater than 80, greater than 100. I'll make 200 the right child of 100, but we're still in balance. All right? And then I removed 2. Follow the search path. We reach this leaf 2. That's the easy case of removal. Then we insert 150. So greater than 80, greater than 100, less than 200. We get 150 here. This is in balance. This is in balance. The left is just one taller than the right. This is in balance. The right is just one taller than the left. And this is in balance. The right is just one taller than the left. Okay? And then we remove 75. That's the leaf case, easy. We're in balance here. Here we have a problem. Right? Now, this is the first time we've looked at a situation where we're going to do a rotation because of a remove. And what happens when you do a remove? You made one side too short. But the patterns of rotation are always done relative to the taller side. Relative to the taller side. So we get to this here. We see our right side is too taller than the left. We look at the right side. It's taller on its right. So I have the right case. All right? So I'll transform this. All right? This is our S. This is our X. This is our A. This is our B. This is our C. So this will get transformed into this. That is, X became the root of the subtree, which in this case is also the tree. S's left became 80. 80's left stayed the same, or S's left stays the same. S's right becomes that subtree B. And X's right stays the same. So that was that right single rotation that I showed you the pattern of just a minute ago. All right. Now we, what did we do there? That was inserting one, oh no, that was removing 75. We'll insert 300. We'll insert 125. Follow this path down. Put the 125 here. Everybody's still in balance. Then we'll insert the 110. So we follow this path here. We work our way back, in balance, out of balance. The left side is 2 taller than right. This is the smallest case of our left-left single rotation. All right, so I'm just going to do this in place here. So remember, 125 will become the root of this subtree. 110 will stay in its left child. Its right child becomes 150. Then I go ahead and remove 150. That's an easy leaf case. But as I work my way back up, I see I'm always in balance still. And then I insert 95. Come here, insert the 95. And imbalance, 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 and imbalance. And then I insert the 130. It's going to follow this search path. And I'll get the 130 here. And then I insert 3. Follow this path. Imbalance, 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 still imbalance. And then I insert 25. I'll follow this path here. I'll still stay in balance. And then I insert 97. I'll follow this path. Put the 97 there. Imbalance, imbalance, out of balance. All right, because 90's left child is empty, but its right child is height 2, or has 2 nodes, height 1. All right. So this is the single rotation on the right side. All right, so 95 will become the new root of the subtree, with 90 as its left child and 97 as its right. So we'll be okay there. Then I remove 300. Come back up here. I'm out of balance because the left side's too taller than the right. But this is a case we never had in the insert case. Right? We have to figure out what rotation to do. How did we figure that out before? Well, we know we're too tall on the left, but we look at the left and it's equal balance. That could never happen in the insert case because we wouldn't have changed the height of the tree. All right. The reason it happens in the remove case is because we made one side smaller, but to decide how to rotate, we look at the taller side, which we didn't change as a result of the remove. All right. So what we'll actually do here is a single rotation. All right, so we'll rotate this so that we'll have 125, 110, the 200, and the 130. All right, that would be the single rotation pattern from that. All right, that subtree is now in balance. And when we get here, what do we have as our height? 0, 1, 2. This height is 0, 1, 2. We're still in balance, we're okay. Notice, if this 130 would have been here, I guess in this case we would have still been okay. But it can happen when you do the rotation with remove. Right? We'll see some patterns next time for that. Right? That this tree is shorter than it was before, and if it was on the shorter side, I might have to do another rotation. And in the worst case, I'll have to do a rotation all the way up the path. All right? I'll show you a pattern that can yield that called a Fibonacci tree pattern that we'll see next time. Okay? All right.